Here we go. We're doing algebra review. These just say factor. They don't say solve. There's nothing about equal to 0, so we don't have to do that, but we could. When we're factoring, this one's a trinomial. Okay, it's got 3 parts. So remember, we're going to try to break it up into 2 sets of parentheses. We need to think of 2 numbers that multiply together to get which one? 20. We need 2 numbers that multiply together to get me 20. So Alondra, what numbers multiply to get me 20? 5 and 4, 10 and 2, 20 and 1. One of those combinations, 5 and 4, 10 and 2, 20 and 1, have to add or subtract to get me -1. Alondra, which one's going to add or subtract to get me -1? 5 and 4. Good. She's picking those 2. So 5 and 4. So she's going to, the 5 is negative, a -5, a +4. Let's double check. -5 plus 4. Yep, that gets me -1x. And -5 times 4, that gets me -20 like I want it. I'm done there. I didn't have to do anything else. It didn't say set it equal to 0. It didn't say solve. It just said factor. So now that I've set it up and I got my answer, I'm done. If it said solve or set equal to 0, that's when we would continue with that and change signs and everything else. Questions on 10? Number 11. We're factoring again. What's the difference here on number 11? It's got a 3 in front. It has a leading coefficient. We don't like solving with a leading coefficient. It makes it harder. We can't just do normal factoring rules. But what do we need to do differently when there's a 3 in front? We could, if everything was divisible by 3, we could divide by 3, but it's not. So the other thing we can do, remember, is called borrow and payback. We're going to multiply 3 by that last part here. So I'm going to rewrite this polynomial as x squared minus 14x minus 15. I borrowed that 3 and multiplied it by the end. Once you've done that, then it's just a normal factoring problem. All right, so I'm going to try to set this up just like we did the last one. Seth, I need 2 numbers that multiply together to get me 15. 15 and 1. Good choice. 15 and 1, 5 and 3 would be another option. Which one, Seth, do you really want to use, though? He wants to use 15 and 1. What's going to be true about your signs here to get -14? Which one needs to be? Yeah, which one needs to be negative? -15, a +1. Because if he takes that plus that, -15 plus 1, it gets him -14. -15 times 1 gets him -15. Good, he kind of factored it. We're not all the way done yet. Because this is a borrow and payback, we started off by multiplying by 3. We have to do something else here at the end in order to finish it. What do I still need to do here? Divide by 3. We borrowed by 3 in the beginning. Now I'm going to divide by 3. If you can divide it like this first one. 15 divided by 3, that's 5. Done. Okay, that's one factor. This one, I can't divide by 3. It's 1/3. It doesn't work. So if you want to write it as a factor, remember you can pull that 3 out in front, 3x plus 1. It's like multiplying both parts by 3. There's the second answer. Questions on that one? That's factoring. We should be good at factoring by now, hopefully. That's an important skill in algebra. Every single class you take, you got to factor at some point. Number 12, it's just a solving question. We're trying to get x by itself. A reminder that anytime we try to get x by itself, we're always trying to do order of operations in reverse. PEMDAS going the opposite way will get us to our answer. Trying to add or subtract and multiply and divide and all those good chunks. Okay, this one's a little bit different because you've got those numbers in front. I don't like doing these types of problems as much with the numbers in front because it gives kids a wrong sense of what to do first. But guesses on what we should do to make this problem easier? We can distribute here. The reason we can distribute is there's no exponent. If there was an exponent, I couldn't do that. But there's no exponent on the outside of the parentheses, so we can go ahead and multiply this out. 6x plus 6 equals 4x plus 12. Once I've done that, Zaru, what do you want to do next? Yep. Let's move the x's to the same side. So we're condensing our x's, combining like terms. So Zaru said go ahead and subtract 4x from both sides. Now we've got 2x plus 6 equals 12. Minus 6, we're doing order of operations in reverse. Now that we only have x one time, We're trying to add or subtract next. So we said subtract 6 from both sides. 2x is 6. Last thing, divide by 2, divide by 2. X equals 3. Easy one. Again, that's an Algebra 1 question. That's not the one I'm worried about for our final. We're reviewing that way you don't forget those simple things. Problems like 1 through 4 where we had to do logarithms are the ones I'm really more concerned about. Another really important question, we're solving for y and graphing. Okay, right now we've got 3x plus 6y equals negative 12. In order to graph that, we want to get y by itself. And so in order to get y by itself, again, I'm thinking PEMDAS in reverse. Trying to add or subtract things and then multiply or divide to work from there. So if I want to solve that thing, Courtney, what do you want to do first here? If I want to get y by itself, what can I get rid of? What can I add or subtract from the 6y side? We want to get rid of the x's first. We want to move those over, okay, because that 6 is being multiplied, so we want to do something different for that. We're going to subtract 3x from both sides. 6y equals negative 3x minus 12. We subtract that 3x over. We're adding or subtracting first. Once we've done that, Mason, what else can I do next to get y by itself? What do I need to do to get y by itself? It's being multiplied, so if it's being multiplied, how do I get rid of it? Divide by 6. Divide by 6, divide by 6, divide by 6, everything by 6. That cancels. Y equals negative 3 over 6. I'm going to reduce that to negative 1/2. X. Negative 12 divided by 6 is negative 2. There's my equation. Y equals negative 1/2 x minus 2. I'm going to try and graph that. It's in standard form now, or it's in slope-intercept form. I can graph it. Sabrina, if I want to graph that thing, where am I going to start? At negative 2. This is her y-intercept, remember? And so she's going to start on the y-axis down here at negative 2. This negative 1/2 right there, the thing in front of your x, that's her slope. And for slope, we always think rise over run. So if my slope's negative 1/2, Sabrina, what am I going to do with that? Down 1 and then what? Right 2. Guys, down 1, right 2. Down 1, right 2. Down 1, right 2. There's my graph. I could always go up and left, do the exact opposite. There's my line. Questions on that chunk? That should be the review chunk. If you've forgotten something, remind yourself of it. That's stuff we learned back in Algebra 1. Let's remember. All right, here we go. We're solving logs. Remember the key to the log chapter. Okay, there was one thing we talked about all the time, which was inverses. What is the exact opposite of log base 6? If you can remember that, you're going to be good at this chapter. Okay, if you've forgotten that, that's what we need to remind ourselves of today. What is the opposite? I want to get rid of log base 6. What is the exact opposite of log base 6? 6 to that power. Okay, that's what we talked about all the time. 6 to that power. So I'm going to raise this side to a 6 and that side to a 6. So it's like this. 6 log base 6 of x equals 6 to the negative 3. We are raising both sides to the 6th power. That is the opposite of log base 6. Now I've got 6 and log base 6 over here, so that cancels like we wanted it to. That's why we did 6 to a power, because they're opposites. I then get x is equal to 6 to the negative 3. Just a matter of figuring that out. And here's a reminder. What does the negative in an exponent do? Make it a decimal. More specifically, I think somebody was starting to say it. A negative exponent makes it a reciprocal. Makes it a reciprocal, or in other words, this thing right here is the exact same thing as 1 over 6 to the 3rd power. That's why you're getting a decimal. Okay? So it'd be easier to write this as a fraction. If I want to take 6 to the 3rd power, that gets me 216. So my answer here is 1 over 216. that's the answer I'm looking for here. I don't want to necessarily do a decimal. I just took 6 to the third power. 6 times 6 times 6 gets me 216 on bottom. Questions on 1. They're not crazy hard problems, but it's been a minute since we've done them. You guys actually did really well in this chapter when we learned it originally. Number 2 says 1 over 8 equals 16 to the x minus 4. We're trying to get x by itself. It's stuck in an exponent, so we could do some different things with logs. Okay, but this is one that we tried to do without logs. Something we talked about that would make this problem really easy is if both of these things were the same base. Like this, if it were 2 to the x equals 2 to the 4th power, what's x got to be? 4, right? If the bases are the same, then you don't really care about the bases, and you just mess with the exponents. That's what we're doing here. We are trying to rewrite both sides to be the same base as some number to a power. If you remember, we talked about 3 specific numbers that made it the easiest to do normally. What 3 numbers do we want to try to rewrite them as? 2, 3, and 5. 2, 3, and 5. If you could rewrite each side as 2, 3, or 5, it was going to be easier to do. So what number do you think I want to rewrite 1/8 to be? 2, 3, or 5? 2. All right, I'm going to rewrite the other side as 2 to a power as well. So I need to rewrite 1/8 as 2 to some power. It's getting me a fraction. What has to be true about my exponent in order to change 2 into a fraction? It's got to be negative. Okay, 2's got to be negative, so it's going to be a negative power. And then I need to think in my brain, all right, 2 to what power gets me 8? 3, not 2 times 4, but 2 times 2 is 4, and then times 2 one more time gets me 8, so that's 3. So that's a negative 3 over there. These two numbers, 1/8 and 2 to the negative 3rd, are the same. Okay, they're the same number. We just rewrote it in a different way. On the other side, I got 16. What could I rewrite 16 as? 2 to the 4th power. Okay, again, if you don't remember these things, you can always use your calculator. 2 to the 3rd power, 2 to the 3rd, yeah, that gets me 8. 2 to the 4th, 2 to the 4th, yeah, that gets me 16. We're just rewriting them as new bases. There we go, 2 to the 4th. 2 to the 4th, you're going to multiply that by the exponent that's already there, that x minus 4. Remember, we put that in parentheses when we work through that. Now that I've done that chunk, what can I do with both sides here? I've got the same base. I'm going to do that. Yep, I'm going to distribute that 4 to both things. What about my 2's? They're the same on both sides. If they're the same on both sides, we can cancel those things. Negative 3 equals 4x minus 16. I distributed that 4. And now it's just a simple solve. We're trying to get x by itself, so we're going to do order of operations in reverse to try to get it by itself. So I'm going to add 16. Negative 3 plus 16 is 13. What else do I need to do? Divide by 4, divide by 4. X equals 13 over 4. Bless you. A little bit tougher of a problem. Not every problem is going to be easy. That's one of those ones that's going to separate you getting an A and maybe an A minus or a B and a B plus or whatever it is. Look at it and understand what we did. We saw exponents. The easiest way to deal with that was to rewrite them as the same base. So we thought of 2, 3, or 5. We rewrote them both with a base of 2. Once we did that, we could cancel and then solve. Let's go to number 3. Number 3, we're solving 3 to the x minus 5 equals 13. We are trying to get x by itself. So we want to get rid of everything else before we deal with that x. What could I do first? Add 5. Add 5. 3 to the x equals 18. This is what this chapter was all about, was solving a problem like this. 3 to a power is 18. Well, I know 3 squared is 9, and 3 cubed is 27. Right? 3 squared is 9, and 3 cubed is 27. So what do you know is true about your x? It's between 2 and 3, right? That's the only way we can make it's a decimal. It's some number between 2 and 3. I don't know what it is. We need to solve that. Right now I've got 3 to some power. I want to get rid of that 3. What is the opposite of 3 to some power? The opposite of 3 to a power is log base 3. We are going to take log base 3 of both sides. Whatever you do to one side, you do to the other. So if I take log base 3 on this side, I still got 3x left over. Log base 3 on this side is going to get me 18. What can I do when I have log base 3 and 3 to a power? Those two things cancel. They're opposites of each other. That's why we wrote it the way we did. Those two things cancel, leaving me just x. On the other side, we're doing log base 3 of 18. There were 2 ways of doing this. You could do it the long way in your calculator. The long way in your calculator is taking the log of 18 divided by the log of 3. The log of the number divided by the log of the base. That was one way we did it. Okay, you type that in, you get an answer. Remember, you also have a nice button in your calculator to do this as well. Math button. You scroll to log base. So everybody look at me what we're doing here. Hit the log or the math button. And then you can scroll down here to log base. That's the one we want, log base. You hit enter. And then all you got to do is type it in. Log base 3 of 18. What did we say our number need to be between? 2 and 3. Let's see if that's true. 2.6309. Okay, remember we went quite a few decimals on these 4 decimals. It'll tell you on the final. So what we just found out was 3 to that power, 3 to that 2.63092975. If I plugged it into that number, it's going to get me 18 like I wanted. That's what I was looking for. 2.6309. Bless you. 2.3069? 6039. My bad. Questions on that one? Last one, number 4. This one's the easiest one of the log questions by far. Log base 6 of 2x plus 1 equals log base 6 of 7. What can I do on both sides for this problem? Cancel the logs. You have the same thing on both sides. All right, it's pretty much the same as the problem above it, where we had 2 on both sides and we could cancel it. Same thing's here. Now I got log base 6 on both sides. I can cancel. So all I have left over then is 2x plus 1 equals 7. Minus 1, minus 1. Divide by 2, divide by 2. Cancel and solve. Questions on that one? All right, let's keep working. Number 5 says you have 4 shirts. Now we're doing probability. These should be easy ones. You have 4 shirts, 3 pairs of pants, 2 pairs of shoes that all coordinate. How many outfits can you put together for spring break? How many different things are you choosing? You got 3 choices, and they're all separate. You're picking shirts, you're picking pants, you're picking shoes. How many shirts do I have to choose from? Pants and shoes. I want this and that and that. Remember, when it's and, we multiply. 4 times 3 is 12, times 2, 24 combos. That's how many different outfits I could wear, 24. However many things you have, we multiplied them together, we got an answer. Number 7, Key Club has 15 members. How many different ways can you pick the president, the vice president, the secretary, and the treasurer? This time you're picking from one pool. The last one we had pants and shoes and shirts. Here we have 15 people that are all going for 4 spots. Okay? So there's different ways of doing it. You could say 4 lines. How many people out of those 15 could be president? 15. Once you've picked a president, then 14, and then 13. Oh, my fault. I'm picking 5 things. And then 11, because I have a treasurer as well. You could do that. You could take 15 times 14 times 13 times 12 times 11. Oh, my bad. I can't count. Counting is hard. I've got 4 things. Sorry. I saw vice and president and broke it up into 2 again. I have 4 things. Or I could do combinations or permutations. Does order matter? Is this thing organized at all? Yeah, because someone's at the top and then someone next and that one. So is that NPR or NCR? That's NPR, 15, place 4. That's what we're trying to do here. So I'm going to go calculator, 15, math button, over to probability, down to NPR, 15, NPR 4. 32,760 different ways of doing that. Couple more. Stay with me, please. 4 red pencils, 6 green pencils, and 5 yellow pencils are in a jar. Once a pencil is selected, it is not replaced. What's the probability the first one's green and the second one's red? How many pencils do I have altogether? 15. You're making 2 different selections. The first pencil's green, so I've got 6 of them. Then I'm doing it again, so I want a green pencil and then the next one being red. So it's not replaced. How many pencils are left in the box? 14, and how many of them are red? 4. We are multiplying through. You get 24, or whatever 15 times 14 is. $210. I'm not going to reduce right now. Questions there? I'm not going to do number 8. That's very similar to it, and I'm trying to save time. Let's go to this one. This was the thing we were the worst at on this test, on this probability test that we took. Here we go. 500 teenagers were asked if they had braces or not. 500 teenagers. Probability of braces. So out of 500, because I'm looking at everybody, how many of them had braces? 324. That's the total amount of braces. So 324 out of 500. Done with the first one. The next one, probability that it's a male and no braces. So we got 500 people total to pick from. I want men that have no braces. 144 for that one. The last one is the one we struggle with, the probability of braces out of females. Okay, given that they're a female, this is what we struggled with. Which number is going to go on bottom? 320, because it's showing you it's a fraction. On bottom, you want to put the total amount of females, which is 320. Yep. No, because it's male and no braces. So you would want to pick both categories. Male no braces is 144. Okay? 320 here, what number is going to go on top? 288, because it's already given that it's female. When it says given female, I don't care about any other row except for this one. I want female, so that's why it's 320 on bottom. How many of them have braces? 288. Questions on that review? Nope. I want male and no braces. 180 is just the men. I want men with no braces. So 144 is the people that are men without any braces.